In previous class, we seen some object-oriented language concepts, right? Object-oriented language concepts, right? Today we will continue object-oriented language concepts. So today we'll see what is method overloading. What is method overloading? Any idea about what is method loading? Method overloading? Writing same function, right? Method name is same, different parameters is called method overloading. Writing method name is same, but different arguments is called what? Method overloading. So here we can write the same method name, but parameters are different. Parameters are different. At least order must be different. Then we call method overloading. What is the advantage of this method overloading? What is the advantage of this method overloading? So we can take same method name based on the parameter we are passing. It executes, no, not similar functionality. Method name is same. Functionality is different. Internal, this is called functionality. Yep, you are almost real exact same. Method name is same. Functionality is same, but different arguments. Okay. So here, see, method name is add. Method name is add. It performing addition operation. It performing addition operation. Addition operation. But first one taking two arguments, and next one taking what? Three arguments. First one performing operation, arithmetic operation on two arguments. Next one performing arithmetic operation on three arguments. If you pass two arguments by calling add, first method will execute. If you pass, method name is same. If you pass three arguments, it will execute second function. So this is the advantage. We can take same method name, based on the arguments you are passing, it will execute corresponding method. So this is called method overloading. In procedural oriented language, we don't have this feature. In procedural oriented language, if you take same method name, it will give error. We cannot take same method name. So we have to take different names. If you take different names, remembering method names is difficult. So to solve that problem, object-oriented languages introduces this feature. Object-oriented languages introduces this feature. Okay. So let's execute this one. I'm going to open our project. So we have created a project in different location. So we are created under C drive, under users, under username, in this desktop. So here we have quality thought. Under this one, we created Spark and Scala. In this one, batch 3. In this one, workspace. In this one, we have Scala. Sorry, first. So we are using Scala, right? So this is our project. Let's select this one. Open in same new window. So this one, right? So what I'm doing, I'm pasting my code. So here in main object, I'm creating arithmetic class object. Then I'm calling add function or method by passing two arguments. Then this function will execute. I'm calling add function by passing three arguments. this function will execute. Let's run this one. So we got first to 2 value addition is 30, next to 3 value addition is 60. And next important one, inheritance. Inheritance means acquiring one class properties and methods into another class. Getting or acquiring parent class properties and methods into child class is called inheritance. What is the advantage of inheritance? So parent class has reusability. Yes, parent class has 10 variables and 20 functions. 20 functions. Then whenever child inherits, inherits, inherits parent, child inherits parent, then all parent variables, all parent properties, properties means variables, variables plus methods, methods available plus, and child may have its own properties and methods. So all the parent methods are available to child class plus child own properties and child own methods. So child automatically gets all the parent properties and methods. This is the advantage. Example, see, I'm writing a class loan. This class contains 20 methods, 20 methods, and I'm writing class gold loan, gold loan. So this one contain 20 same as loan plus 10 different methods, 10 different methods, 10 different methods. Okay, we have same as parent, same as parent, same as loan class. It has 20 same 20 methods plus 10 different methods. So what is the problem with this approach? We have to write the same code in gold loan class. We have to write same code in gold loan class plus different methods. So here duplicate code is, so duplicate code in gold loan class. Already loan class contain similar uh, 20 methods. So instead of rewriting same 20 methods in gold loan class, if you create relation, if you create relation, so here to create relation we use extends, extends and loan. If you create relation between this one, no need to write this logic. It will reduce duplicate code. Automatically, if you create relation, all parent class variables and methods is available to gold loan class. So we are resolving duplicate code. So this is one of the main reason we are going for inheritance, reusability. Example, employee class has salary variable, programmer extends employee, then in programmer class we defined only bonus, then salary variable is by default available to programmer class. Let's write this program and execute. When I create programmer class, it gets automatically both the data, parent data and child data. Let's right click on this one, run main object. So we got both the data, parent data, child data. When you create a parent child object, you will get both the data. So this is the advantage of inheritance. Advantage of inheritance. Next one, very important concept is traits. What is trait? What is trait? Trait means it is a interface, it is equivalent to interface in Java. Interface in Java. What is interface in Java? Interface contain only method declaration. Interfaces contain only method declaration. There is no implementation. So traits are equivalent to interfaces in Java. Traits contain only method declaration. Traits contain only method declaration. It contain only method declaration. Then if any class extends a trait, here we create a relation between trait and class by using extends keyword. No need to use implements like Java. We can use both extends keyword for extending traits and classes. Extending trait and classes. So here I am extending trait XYZ. If any class extends trait, the class responsibility is to provide implementation to abstract methods of trait. So this is the first responsibility of trait. Without providing implementation of this method, then we cannot compile this class. We cannot use this class. Without providing implementation of abstract methods of trait, we cannot compile this class. We cannot create object of this class. Okay, so that's why we are providing implementation. Then I'm creating a class object. I'm calling print method. Let me first execute this complete program. So it is executed and got output hello. Okay, next one, next scenario. If a class extends a trait but does not implement members declared in that trait. So class is extended trait, but class is not assumed, this class is not provided implementation of this print, and we have some hello implementation. So class is extended XYZ but not provided implementation to print method. Then first responsibility of class is, if any class extends any trait, that class is responsible to provide implementation of all abstract methods. But this class extended XYZ but not provided implementation of print method. Then we can make this class as abstract class. Otherwise, this class code is not compiled. We can make this class as abstract. We can make this class as abstract. Otherwise, this A class will not compile. So what we are doing, next example, say this is a XYZ and print class A extends XYZ but not provided print method implementation. Then we can make it as abstract. Abstract classes may contain abstract methods. It may contain fully implemented methods. Abstract class may contain fully implemented methods and may contain abstract methods. For abstract classes, we cannot create objects. For abstract classes, we cannot create objects. Then what is the advantage of this abstract class? Abstract class can be available only for its child classes. Abstract class objects available only for this child class objects. Okay. So implementing multiple traits. So a class can implement any number of traits. A class can implement any number of traits. It is not restricted to implement only one trait. A class can implement any number of traits. Example, see here, I have a trait XYZ, I have trait display. Then class A extends XYZ. If any class implementing multiple interfaces, multiple traits, we create a relation like this. A extends first interface with second interface, with third interface, with fourth interface. Like that, we can specify any number of interfaces. Then this class has to provide implementation to this interface methods. This class is responsible to provide implementation of this interface and this interface. Without providing these two interfaces methods, we cannot compile this class. You got it right? So let me execute this one. Let's execute this program. So we got execute from this is trait XYZ and this is display trait. Whatever the logic we implemented in these two methods, we got as a output. Okay. Next, very important feature of trait is Scala trait having abstract and non-abstract methods. Abstract and non-abstract methods. What is this one? Just now we said traits is like a interface. Interface, right? Interface in Java. In Java, interfaces contain only methods. Interfaces contain only method declaration. There is no implementation. But here Scala trait contain both methods. Trait contain both the methods. It means traits are acting like interfaces and abstract class features of Java. Traits are working like both interfaces and abstract features of Java. Similar to that, it is working like interfaces plus abstract classes of Java. We can create abstract classes by using abstract keyword, but trait can behave both the features. One is interface features and another one is abstract features. Only one thing, for traits we cannot create an object directly. For traits we cannot create objects directly. So this is the only difference with difference. So let's class A extends XYZ. So it is available abstract method and non-abstract method. Let me create this one. Let's right click on this one. Let's run main object. So we got both the methods output, right? Both the methods output. So do you have any queries in today's up to this concept? Yep. Okay. So that's it for today class. Tomorrow we'll start from Spark core programming.